Everyone, Data Science with Sam back with another vlog. Last week, OpenAI released their AgentKit, a new agentic workflow system that's going to help you to build your agents tied to the other multi-agent system, even integrate that with MCP or any other external services to help you build some autonomous system. Have you tried it yet? If not, in this vlog, I'm going to show you that how I can build an agentic workflow system to help me with digesting some research paper or manuscripts based on various AI-related topics. So this is the agentic workflow that I built for just to get all the details about some of the research paper. So it first starts with that how you can build that starting from the start node. So this is a start node that's kind of like, start the agentic process. You can provide a variable as an input as text, because most of the time when you ask something to the agent, you will provide a textual prompt. So input should be as a text for the start node. The next thing is that you connect this start node with the AI topic classifier. The reason we need classification because there are various AI topics out there, and I want to make sure that the research paper that I'm receiving from the agent are filtered by different topics. It can be either machine learning, or it can be deep learning, or even some research paper related to transformers or neural networks. So that's why the topic classifier is very important. The instruction that I shared in the topic classifier is you're an AI research topic classifier. Given a user's request, for example, find recent breakthroughs in diffusion model, classify it into one of the following: machine learning, deep learning, MERS, neural network, and data science algorithms. So this classifier algorithms, as per agents, is going to take the user request, classify that which topic that user wants the agent to provide examples for, and based on that, it break it down and pass it to the next agent. In the classifier agent, there are a couple of things that we need to make sure that we pass it there. First is the output format. So the output format of the topic classifier will be in JSON format, and it's mainly providing a topic underscore class variable in string format, which gets passed to the next agent with the topic classification name. For example, if a user requesting for machine learning topic, then the machine learning verbiage will be passed in the topic underscore class variable to the next agent. Other than that, you can always play with the reasoning effort. You can select it to high, so that will help the node to reason better based on the user prompt. Now, the next step is that we are adding an EFOLS condition block, and that EFOLS condition block will take the topic classifier output as an input level. Now, based on the input, it will classify which particular node it will pass delegate the request to. Like, for example, in the EFOLS block, we have 5 different parameters. For example, if the topic underscore class variable contains machine learning keyword value, then it will take it as a machine learning keyword value, and it will pass it to the machine learning researcher agent based on the variable. If the input variable contains deep learning as the keyword value, then it will propagate that to the deep learning specific researcher agent. Similarly, other else if blocks determine which particular node agent will be called based on the user keyword value. So after you develop the EFOLS block, the next step is to connect the EFOLS block with multiple machine learning researcher agent. So this researcher agent are going to receive the input from the EFOLS block, and based on the keyword value, it will filter down that particular keyword, go to website and different website and do the web search based on the keyword, retrieve relevant research paper, and then pass it to the summarizer agent. Let's see how it does. So let me open this machine learning researcher agent. What is it doing is that in the instructions section, I'm passing it as you are an AI research analyst specializing in machine learning. Use the connected web search MCP to find recent papers from arXiv, ACL, or NewRecipe, or any reported journal related to recent models, interpretability, gradient model, and observation trends. For research paper, summarize title, publication date, core contribution, dataset used, and any other relevant details. You can refine this instruction. You can provide more specific instruction to get more granular level details from a manuscript. Now, one of the main component of this researcher agent that you need to give the agent capability to go out there and search in the website and find relevant research paper there. And for that, we need to have the MCP enabled. So that's why this tool section is very much important, where I already selected the web search, which means that once the machine learning researcher agent gets called, based on the keyword that it's invoking from the EFOLS block, it will go out there, search for machine learning relevant research papers for last 30 days and provide output to the next node. So other than that, usually the output format, we are expecting that output format will receive in a JSON format, and it will get passed to the summarizer agent, and summarizer agent will do the final messaging before it provides output to the user. You can definitely keep the reasoning effort as high, but it will take some time. The more reasoning means it will take more time for the model to provide you details. So you can always play with that option. Now, let me show you some other examples. For deep learning, the instruction remains the same. However, I need to tweak some of the keywords there. Like here, I changed the machine learning keywords and change it to like deep learning, as well as I also provided some deep learning specific terminologies. If you're looking for some deep learning related research paper, it should be something related to CNNs or GANs, artificial models, something like that. So you need to provide some explicit keywords specific to that AI research topic. So that way the agent will be able to understand your request better. Over here also, you need to make sure that you turn on the MCP web search tool feature. Otherwise, it will be difficult for agent to understand what's going on. For the output format, you can keep it as JSON across the board. So same for transformer. I changed the verbiage a little bit in the instruction section to make sure that the MCP web search tool will only fetch details depending upon the transformer architecture and relevant topics. Same with the neural network. In the neural network, I basically wanted to emphasize on some of the architectural stuff, and you can always play with this one. Like one of the things is that in the neural networks area, there are a lot of research happening in the activation functions area, how hidden layers and stuff. I think I can probably add the hidden layer as well. So please use your expertise in the AI space and tweak this instruction in order to help the agent retrieve better results and also provide you more accurate research paper related information. And finally, I added a data science agent. This is kind of one of my favorites because I wanted to make sure that the data scientist will also be able to read and get some of the research paper related information from this agent. And for the data science stuff, I mainly focus on some of the, conventional data science techniques like data wrangling, feature engineering, clustering, and ensemble methods. You can add more stuff over here. For example, if you want to know more about markup chain models, so let's just add there. So maybe there is some research happening in the last 30 days related to markup chain models could be passed here. But again, this is all optional because sometimes it's possible that, there are no research happened for that particular related to topic within a span of 30 days. So in that case, you might have to extend that time period from 30 days to 2 years to 3 years to get better results from the agent. All right. Now, the final thing is that summarizer agent. What we are doing in the summarizer agent. In the summarizer agent, this is a research summarizer. So research summarizer agent will get the results from each and every topic related agent. And then it will summarize all the contents together, and it will format it in a markdown format with sections like overview, key methods, emerging trends, citations, and other stuff. And then it will pass that final output results to the user. And here for the output format, I kept it as like a text format. So in that way, user will receive everything in textual format because it will be difficult for user to, parse a JSON format. The textual format should be a standard output format for summarizer agent. So that's it. Now let me go and run a preview. I do have a few sample prompts. So let's start with transform. All right. You can also go take a break now because this preview section might take a little while. But depending upon the time range, since we only specified 30 days, so I don't think so. The agent will take a lot of time to retrieve relevant research paper that were published in last 1 month. As you can see that first it moves into the AI topic classifier. And it goes through that in EFOLS block. In the topic classifier section, the important thing is that based on the user request, the agent was able to correctly identify that user is looking for some research paper related to transformers architecture. So it's kind of like, move on to the EFOLS section, and there it's looking for some sort of a transformer related research paper in archive or any other relevant journals. And this section will take some time because as the agent is going out there, looking for so many research papers out there related to transformer and giving you a very comprehensive report. So you can always take a break, go get a cup of coffee and come back and see what's going on. All right. It seems like the agent was able to give us a comprehensive report of all the research papers that were published in the last 30 days related to transformers. Now let's just go over that a little bit. For example, let's say this research paper, Compressed Convolutional Attention Curve. It was released in 2025, 10/6. So let me just try to research it a little bit. I'm going to take a top 8 and I'll probably just pull it up. So let me just share my screen so you can see that what research paper that the agent suggested me to look at. So this is the research paper, Compressed Convolutional Attention, Efficient Attention in a Compressed Latent Space. If you go over that research paper, you would find that this is somewhat related to the transformers. So I can definitely provide my confirmation that that agent was able to give me a proper research paper relevant to the topic. So I would definitely encourage you to, try and test and build this kind of agent and tweak the instruction and see how you can get better result. For example, I have also worked on some of the other prompts as well to get some research paper related to data science, deep learning, or even computer vision. So try it out, and I will definitely share some of the instructions in the YouTube vlog descriptions that will give you more information about how you can build this kind of agent, step by step. So please take a look at the descriptions and try to build something in the AgentKit. And also, if you have any other ideas of building agentic workflow using this new OpenAI platform, feel free to share that in the comments so I can probably use some of them as an example for my next vlog. That's all for today. Till then, goodbye. Thank you.